What we have here is a groundwater model, and also for watershed we'll put a little bit on the surface too. It'll show the interactions between the surface water, the groundwater, and little septic tanks and injection wells and pumping wells that you get for your drinking water. This is built by the University of Wisconsin-Stevens Point, and we'll get started. On this right side we have the outgoing, where the water will be going out, and on the left side will be the water going in. This will create our flow of groundwater from left to right. As we continue moving into putting injections into our Artesian aquifer on the bottom here, which is a coarse gravel that allows a higher concentration of water to flow through it than this upper lighter layer of sand. Right in here in the middle is a confining layer of silt and clay, and that will help try and separate these two layers to have two distinct layers, as if you were be in glacial till up north, or if we have different types of geology all over the place. So we'll be putting red dye into the deeper injection well, into the gravel. And then I'll follow with a little bit of water to help expedite the process. So we have a little bit of contamination is what this is going to be representing. Going into the bottom, it's already beginning to flow. And in the upper lighter sand unit, we'll have a little bit of blue. Now, to truly represent a surface topography and different activities that we have at the surface, like parking lots or drainage units, we're going to have a little bit of green go into a parking lot on top. And let's just say that we have a little bit of a rainstorm go on that parking lot and help expedite the process. See how it spreads as a gusher. Now if you look at the septic tank here, we have an influx of groundwater going into the septic tank, which could also represent a sewer holding tank, say for your sewage system in town or whatever you have. So this is mostly representing a country setting. We're out in the rural parts of America, and so you'll have the personal wells and other systems of getting rid of your wastewater and obtaining clean fresh water. If you can see the lake, we also have a bit of green coming through it. As I take off a little bit of water from it, that'll create a draw from the groundwater to try and get more of that water into it. Now, our red dye down in the Artesian aquifer below is going behind the label, and it's already becoming close to this other well that we have for obtaining some samples. So we'll try and draw from it and see if we can obtain some contaminated water. I am drawing clean water into my house from the bottom aquifer, the lower one, and as soon as I start pulling red dye, I'll let you know. And if you notice, the lake actually has red and green in it now. The red is already coming through the Artesian well from below up into the lake. And around our neck of the woods in Appalachia, we have Watauga Lake, or Lake Watauga. And during the wintertime, they draw that lake out and make it real low so that it doesn't have too much water in the springtime with snow melt and with the spring rains. So it could either simulate that, or out west, they'll draw water directly from rivers and lakes to help with irrigation. So that represents both. And the point of this whole model is to show that everything is interconnected. And you cannot abuse our natural resources. You cannot just be changing your oil of your truck or car at home and decide not to take it to the auto dealership or to the auto parts place and just dump it on your yard. You cannot do that because your neighbors are going to be drinking that oil. And that may not be right away. If you notice that the red is traveling much faster already out to here than the blue. The blue does not go very fast because it is a less porous material. It does not allow for a large amount of water flow. So if we were to do this in real world, things that were deposited into the soils in the 60s and 70s or even older, we are now just feeling the effects. And to be able to clean the entire aquifer of North America would take a long time. And in this shallow well, I am beginning to pull up red dye that was going through the microfractures of the confining layer to show that not all wells are created perfectly. And this is realistic, that the water does go through other layers if we are drilling holes through them. And that's applicable to not just water, but oil and fracking. How about you say we have another rainstorm? Boy, isn't that a clean septic tank that we have? If I continue drawing from the shallow well, I'm trying to pull more of that blue towards that pumping well. Right now I'm mostly getting red. Nice clean lake too. Let's try and draw from that. Yummy. Why is the blue going up? It is going up immediately right here, most likely from some sort of draw. I don't know from what, most likely the septic tank as it circulates its matter. But then it's being pulled back down again because I'm drawing it out of the pumping well.
What is the septic tank doing?
The septic tank is, how it works is your house would be dumping mostly into this middle part, and it needs a breather hole to be able to function correctly. And most septic tanks also have what's called a mound, which is the drizzling system. And you cannot see it, but on both sides there are holes to represent that the mound system. And what would happen with our home's septic tank is the solids would be going right down into the bottom, and then any liquids, as it fills up, would be draining into that mound system, which goes into the ground. So if we want to, we can fill up the septic tank a little bit with some more clean water. Try and get that to flush out. And everything mixes together, solids settle out to the bottom, and the rest of the liquid goes out. And that's the idea behind the mound and septic system, is to have it settle out enough where the bad chemicals, the waste, aren't going directly into the ground system. The red is contaminant that has gotten into the lower unit and has traveled all the way through this one, through this pumping well, and found a crack through a fracture through the confining layer into the upper unit and into this pumping well, and is beginning to travel along both above and below the confining layer to our endpoint, which it's already coming out of the other end.
And then the blue is just another contaminant, but going into a different layer?
Exactly. Yep, a different contaminant into the upper layer. And it's very important for homeowners to get water quality checks, probably every 5 to 10 years. Especially if you're in an area, if you have your own well. Yeah, cities and counties have the similar system where they still draw from a major pump, and they do get contaminants. However, they have a system where they filter through all that chemically and using reverse osmosis and all sorts of different purification systems that they have. There are ways for the contaminants to get down that far and to the lower levels. If you take a geologic unit and follow it, more than likely it will crop out at the surface from different mountain belts or other fault layers, and it can be recharged that way. The other ways are from mining, opening up, going down to it, and not only for minerals but also petroleum, fracking. Contaminants do go the other direction. When you pump out, something has to go in, and they put in their used water for the slurry mixture for the drilling. So there are other contaminants. Those aren't quite as nasty or as bad, but the open strip mines that are going down to those units are exposing them to the surface and getting contaminants that we don't want in our drinking water. So I am getting a lot of blue now into this pumping well, and it's actually more of a purple as it's mixing with the red. Here on the far right side?
Further in.
Here? This is an artesian well, and from the bottom here, as it goes up, these are natural springs. This lower layer being so porous and open with the gravel, it has a lot of water flow through it. It actually has a higher pressure than this upper unit, and it will actually stream water up into it, and that's why we have red all the way up into the lake from the bottom unit. A little bit more into the septic tank.
Are you going to put anything cool in that septic tank?
I sure can.
Like a baby root? Yeah.
Someone just flushed the toilet. To recharge our water. All the way across the side here are holes. Each line that you see is a hole for the water to be able to go into the model. Same thing on the right side with all of these holes for it to go out. That's why you see red coming out of the bottom and blue a little bit higher.
So naturally, recharging the aquifer happens how? Just by rainstorms and snow?
Yeah, precisely. Lakes and rivers are a big source of that because it's open water, and anything that we put into the lake, like I'll do now, let's fill it up, have a little rainfall that only went to the surface, it will actually lower to find its groundwater level, which is equal to where the bottle is ending. That is going to be the hydrologic pressure.
So what we could do, as they do in some of the western towns, is to take water and say pump it in the blue one and recharge that with the idea of flushing it out.
Yeah, we can flush the system precisely. Let's do that right now. Put in the lower one and push it out. If we were to draw directly from it, it's still clean water. So it's not fixing the problem, but it's a nice remedy.
But if you recharge your well, you're just pushing it over to your neighbor.
Oh yeah, your neighbor's not going to like you.
They should go live down.
Always live upstream. And you probably can't see it, But this top layer up here now has yellow in it from our septic system. Let's flush out our septic system. We just did a load of dishes. Mmm, yummy. Let's flush out the red one too. And if you notice, when I put water into this far red one, these other wells will actually rise with their pressure.
You may remember reading about many years ago, they recharged some holes around the Denver area. They're putting actually spent nerve gas, and the pressure when they put it in caused the fractures faulting to reactivate. And so they started having the earthquakes in Denver. It's like, what's going on? It's because of that pressure that you just showed there.
Yeah, and that's exactly what's happening for Frac Oil.
Right.
And that's what they're doing. They're putting in not gas, but water. They're using water drilling fluid, either straight down or the down and then horizontal. And they'll just fracture. That's what frac is short for, is fracturing the soil. And then they just draw out the oil, because oil rises. So now we've got yellow in our lake.
We don't know what that means.
We should go fishing in the Mississippi River. Or in Lake Watauga. This all ends as we put more clean water through the bottle into it, and it will flush out the rest of the system, get rid of the food coloring into my bucket, and it'll be clean.
The ocean.
The ocean.
No, it's neat.
And there are other models that University of Wisconsin Stevens Point makes. They have one that would represent more of a karst topography. They have one that can actually show the oil fracking.
Oh, they've made one for that?
Yeah, I think those are new ones. But they've got all sorts of different kinds of models.